So I wanted to show you a little way that I use to multiply polynomials that I think you might like and you might try. But if you like the typical just distributive property, feel free to just stay with that. But this is just an option. So let's say you had a polynomial like, say, 2x plus 7, and I wanted to multiply it by like 3x squared minus 2x plus 6. Okay, so I have a binomial times a trinomial, and that means I have 2 terms and 3 terms. So I know that I'm going to have to do a total of 6 multiplications, and then I'm going to have to look for the like terms and add them together. And sometimes that gets a little bit overwhelming. You get this big long line of terms, and maybe you miss finding and putting like terms together. So what I like to do is I like to create a little grid or a table, a box, if you will, with these dimensions, 2 by 3. Now, it doesn't matter whether you have 2 columns and 3 rows or 3 columns and 2 rows. I usually put the longer one along the top. So like I might say, I'm going to create this box like this. And on the side, it's going to be 2x and positive 7. And so I create this little box with 6 little cells. Now when it's a plus, I don't really put the sign there, like on the 6 and the 7. But if there's a subtraction, I put a negative there. And then I just multiply. So I'll just see which these two go together. I multiply those. So 2 times 3 is 6. X times x squared is x cubed. Okay? Then 2x times minus 2x is negative 4x squared. Then the 2x times the 6 makes 12x. So I'm just going to fill in all the cells by multiplying the row with the column that go to that cell. 7 times 3, that's 21x squared. 7 times negative 2x is minus 14x. And then 7 times 6 is 42. And now all you do is you're going to add all these like terms together. But the nice thing about when you do the box method is that the like terms, if they're already set up in this descending order of power, which you learned was called standard form, then the like terms will always be on the same diagonal. So now look, these are both x squared terms. They're on the same diagonal. These are both the x terms. They're on the same diagonal. Now the constant term down here, there's only one of them, and the highest power term, there's only one of them. So I know we start off with 6x cubed, then we put the 2x squared terms together, which makes, let's see, 17x squared. The 2x terms together makes minus 2x, and then plus 42. So that's just a way, like I said, the box method, I like to do that. I even like to do that sometimes with FOIL. So you could do that with like even your complex numbers. Let's say you had 2 plus 3i, and you wanted to multiply it by 7 minus 5i, something like that, okay? Make a little box that's a 2 by 2, and just do all your multiplications, row with column. So 7 times 2, that's 14. 7 times 3i is 21i. Negative 5i times 2 is negative 10i. And then negative 5i times 3i is negative 15i squared. We know that we're going to turn this into a real number part by substituting a negative 1 for I squared, which makes this into 15. And then my 2 like terms are right here, and then all the top and the bottom there in the upper and upper right hand and lower left hand. So 14 and 15 make 29, and then add the I terms, and that makes plus 11i. Okay? So you can do this for complex number multiplication. You can do this for polynomial multiplication. And it's just kind of a handy like way to stay organized. I like it. I make a lot less errors. I'm always worried when I'm doing multiplications like the one over here, because like there's so many terms, I'm always afraid I'm going to miss something. And even sometimes, let's say I had accidentally forgot to make this as negative 4x squared. As soon as I went and looked and like, oh, these are supposed to be like terms, they're on the same diagonal, I would realize, oh, I forgot to multiply the 2 x's and get x squared. So just a way to think about it. It's a box method, and give it a try. If you like it, keep it. If you don't, go back to your old way.